In this activity, we want to graph this transformed exponential function. But before we do that, let's graph the original function. I've already gone ahead and done a table of values for the original function of y equals 2 to the power of x. Now, you can use any value of x. I've chosen just to use some simple positive values. So let's go ahead and graph the original exponential function up here. So we start off with 0 and 1, 1 and 2, 2 and 4, and then 3 and 8. This is going to continue onwards. However, I am just going to stop there. And if we draw a curved line through them, this exponential function is going to look something like this. Now, previously, we already determined that this exponential function was translated upwards by 2 units. There were no other transformations. So I'm just going to strike out everything that doesn't apply. So when you're translating something upwards by 2 units, what you're doing is you're adding 2 to the y coordinates. So let's go ahead and do that. So 1 plus 2 gives us 3. 2 plus 2 gives us 4. 4 plus 2 gives us 6. 8 plus 2 gives us 10. And 16 plus 2 gives us 18. So I'm going to be using these coordinates as well as these coordinates for my newly transformed exponential function. So let's go ahead and do that up here. All right, so our first coordinate would be 0 and 3, then it would be 1 and 4, then it would be 2 and 6, and last it would be 3 and 10. And as you can see, it is pretty clear that this exponential function has been translated 2 units upwards. Next, let's go ahead and determine some of its properties. So for the domain, x is an element of the real numbers. As you can see here, there's nothing really much to say. In terms of the range, you can see that the transformed exponential function has to be greater than positive 2. So I'm going to say y is greater than 2. And that is actually related to the position of the horizontal asymptote, which I'm going to talk about shortly. There are no x-intercepts. There is a y-intercept. The y-intercept is positive 3. And in terms of the interval of increase or decrease, you can see that as the value of x increases, the value of y increases. So that means it is increasing. All right. So last, let's talk about the horizontal asymptote. So for the original exponential function, the horizontal asymptote was located right over here. It was a horizontal line with an equation of y equals 0. Now, because our exponential function was translated 2 units upwards, that means the horizontal asymptote is also transformed. It is moved 2 units upwards as well, which means its new equation would be y equals 2. So I'm going to put that right over here, and that explains why the range was y has to be greater than 2. It's related to the horizontal